Hello students. So today we'll discuss about 8-noded tetrahedral element or hexahedral. In the last class we discussed 4-noded tetrahedral element or tet4 element, which is a 3-dimensional element. So now we'll discuss 8-noded hexahedral element or hexahedral element, which is a 3-dimensional element too. So here the linear hexahedral element as shown in figure, which has 8 corner nodes with isoparametric coordinates given by zeta, neta and phi. So it is in the coordinates zeta, neta and phi. In the hexahedral, a consistent node numbering scheme must be followed for defining the connectivity. So here a proper node numbering scheme has to be followed to define the connectivity. So how do we follow it? So I'll explain you about that. So first of all, draw an hexahedral element like this. Now in the natural coordinate system, let us take the origin in the middle of the element. If the origin is in the middle of the element, somewhere in the middle of this hexahedral element, so axes will be zeta, neta and phi. 3 axes, that is zeta axis, neta axis and phi axis. Now if this is origin, that is at the midpoint of the element, somewhere at the center of the imagine at the center of the cube as an origin, then the coordinates at that center will be 0 0 0, that is zeta is 0, neta is 0 and phi is 0. So now if you move below, below here to the first node, you can see here the node numbering scheme first. So we'll number it like this. At the bottom part we'll number it 1 2 3 4, and at the top part we'll number continuity from here 5 6 7 8. Okay, so now once the numbering is done, so here now we should write the coordinates of each of this nodes. First, to write the coordinates of the node 1, see, the origin is at the center of the hexahedral element, that is 0 0 0. Now if you move downward, and you can see here the one is, if this is in the middle, origin is in the middle, the one is at the back side, so all the 3 coordinates will be -1, -1 and -1. And you know, in the natural coordinate system the coordinates always varies from -1 to +1. So did you get this? So because it is downward, you're coming down, so negative, and even backward, so all the 3 coordinates is negative, -1, -1, -1. So once you write this coordinate, other coordinates, it is easy to remember. You need not analyze like this each and every coordinate. It is easy to remember. So once you write this coordinate, check the coordinate that is diagonally opposite to first node 1. So the coordinate, the node which is diagonally opposite to this node 1 is 7. So 7 will be completely positive, that is opposite to this. If this is -1, -1, -1, this is plus, plus, plus. Understood? So now you have written these two, 1 and 7. Next we'll move on to the second node. So now this is negative. This is in the negative zeta, negative neta and negative phi coordinate. Now if you move towards 2, then it becomes positive zeta, because you are moving in the zeta axis. Whereas neta positive is like this, so neta still remains in the negative at the bottom, and neta positive is like this, so neta still remains as negative here, and phi positive is like this, so at the downward the phi still remains in the negative. Understand? Or in simple way, just understand, if this is negative, if you are moving in the zeta axis, just make zeta as positive and keep the other 2 as negative itself. Is this clear? Next, writing for the node 4, when you are moving in the neta axis, keep neta as positive and write other 2 as negative. Similarly, when you move in the phi axis, keep phi as positive. See, this is the last one, phi as positive and other 2 as negative itself. Here all the 3 will be negative. Is this clear? Okay. Now writing the other coordinates, you have written 1 7 2 4 5 now. Okay, other one 2, which is the coordinate that is diagonally opposite to 2, it is 8, diagonally opposite. Just imagine in your mind 3-dimensional one. So if this is diagonally opposite, completely opposite coordinates. If this is positive, this is negative. This is negative, negative, so positive, positive. Similarly, you have written this coordinate 5. Diagonally opposite to 5 is 3. So just opposite coordinates, negative, negative, positive here. So positive, positive, negative here. So this coordinate, or diagonally opposite to the 4 is 6. Okay, so minus, plus, minus, plus, minus, minus. Just opposite to this will be 6. Okay, if you write this part correctly, it carries major marks. It carries around 3 marks just for this explanation and this figure itself. Okay, so just be careful while writing this coordinates, and once you write this coordinates correctly, rest all the things is very easy. Okay, so just we'll look on to the other one. The Lagrangian shape function can be written as, so earlier we used to write a different Lagrangian equation. Now for the hexahedral, the Lagrangian shape function, or Lagrangian equation is given as Ni is equals to 1 by 8 1 plus zeta zeta I into, this is multiplication, into 1 plus neta neta I into 1 plus phi phi I. Okay, so now where I is equals to 1 2 3 4 5 6 7 8, since there are 8 nodes there, that we all know it, where zeta I, neta I and phi I represents the coordinates of node I of the element in natural coordinate system. That we already know it, because zeta, neta and phi represents the coordinates in the natural coordinate system. Okay, so now at node 1, consider at node 1. So at node 1, write the coordinates. At node 1, zeta is minus 1, neta is minus 1 and phi is minus 1. So zeta minus 1, neta minus 1 and phi is minus 1. So at node 1, substitute these coordinates values in this Lagrangian equation. So now when you substitute it, n1 is equals to, this is ni, so it becomes, no, for node 1 it is n1. n1 is equals to 1 by 8, and this becomes 1 plus zeta as it is, zeta I is minus 1. So if you substitute minus 1, it becomes 1 minus zeta. Similarly, substitute neta 1 as minus 1, neta 1 is minus 1 here. So substitute this as minus 1, it becomes 1 minus neta. Now substitute phi I is minus 1 here. Substitute phi I as minus 1 here, that is phi 1 as minus 1, so it becomes 1 minus phi. Is this clear? So that's all, very simple. So you have got n1. Okay, similarly, go for node 2. Go for node 2. At node 2, what are the coordinates at node 2? At node 2, the coordinates is 1, minus 1, minus 1. Okay, so 1, minus 1, minus 1. Now the same procedure, just n2. n2 is equals to 1 by f. Substitute the coordinates. If you substitute zeta I as 1, it becomes 1 plus zeta. Able to see it? Yes, yeah. And if you substitute minus 1 here, it becomes 1 minus zeta. If you substitute minus 1 here, it becomes 1 minus phi. Got it? Similarly, substitute all the coordinates. 1 is done, 2 is done. Similarly, substitute the coordinates of 3, 4, 5, 6, 7, 8. So you can see here we have substituted all the coordinates. Okay, 3, 4, 5, 6, 7, 8. Just substitute those coordinates in this in the Lagrangian, function equation. You will arrive at all these equations. Okay, so that's all is the derivation, students. Very simple derivation, but bit important, quite asked many times in the exam, and surprisingly it will be asked for 8 to 10 marks. Okay, so just please be very careful, and especially you have to be very careful in writing this first part. If you don't make any mistake in writing the coordinates, then everything is fine. So any doubt in writing those coordinates, you can ask me anytime. You can call me. Okay, thank you.